Hello, colleagues and doctor. My name is Gabriel Lino Bermúdez. In this subject, we will talk about our final project of structural analysis on logs and exports. Well, next we will see the following. Introduction. Throughout the civil engineer career, a variety of topics have been seen, such as the study of material, soils, hydrology, among others. One of the most big subjects has been related to structure, how there are analysis and determinant as well as basic mathematics subjects. Next, we will see the necessary topics to learn to analyze and determine structures. This time, we will talk about logs and export, where we will see the issues that are necessary to handle this issue. Objective: determine the logs and structures that are generated in a structure by determining the static stability. Structures in engineering. By engineering structures, we mean something that is built. The main structures is which the civil engineering works are bridges, buildings, walls, dams, towers, among others. Such structures are composed of one or more distinct elements arise in such a way that the total structures and its components can remain without appreciable change in geometry during loading and unloading. Who are There are two structures that correspond to the equation of static beings. A being is a linear structural element that works mainly in Byzantine. In beings, the length predominates over the two dimensions and is usually horizontal. Frame. They are structured based on pillars and beams that form joints between beams and pillars maneuvered with three plates of high structural efficiency that permit great heights and free interior space, and of great architectural beauty. Armor is called the structure formed by a set of linear pieces, wood or metal, assembled together, which is used to support the subplane roof of some buildings. Cobbles. They are structured without flexural ridges due to the small cross section in relation to their length. So the leg is transformed into traction cause the cobble to change according to the leg applied to it. They resist only poor temple stretch, therefore respond to logs. Who can see in the following structures, that is our modeling. We can see that the structure is made of frames and beams as shown here. The beams and the frame. Structural analysis. It refers to use of the coefficients of the rectangle materials to find the internal force, the determination and structure that act a resistant structure, such as building or resistant skeleton or of machinery. Next, we have the supports. The support vary according to structure and as the specification indicates. The force and moments we have and direction. Who the giant, roller, or hamburger. One of the is tower where the force of the structure is direction, as well as tower where the beginning moment of the structure. Structural analysis. Reaction calculation. Calculating support reaction is always the first step in analyzing the structure of a structure and is generally the simplest. In bubble calculation, the reaction force as the supports. An example of this is A or B. Due to the force acting to the structure. The number of support of points varies according to the type of structure. These are being, frying, armor, or couple, as well as the amount of correction they will have. An example of this is the frame where we have 4 points in which direction are actinics, both on the x-axis and the y-axis. As we can see in the structure, each support is related depending on the type of the support it has. Some can go to the right or to the left depending on the forward vector, as well as the bending moment. This is a basic structure, so we only have jump and runners who we can see. The direction for is maintained is obtained from the charts, as well as the traveling distance from a point A to a point B. Lags. Under the dimensional requirement the structure can define is necessary to determine the logs that the structures must support. A structure is designed to be for arranging with the specification of the logs acting of the structure. There are two types of logs that structural engineering. These are found in this design. The first type of logs are the logs consisting in the weights on the various structural members and the weights on any object that is permanently attached to the structure. For example, column beams, floors, slab, roofs, walls, windows, plumbing, electrical accessories, or the other mechanical accessories. The second type of shards are actually shards that vary in the magnitude and location. There are many different types of leg logs, such as construction logs, highway bridge logs, rail bridge logs, horseshoe logs, wind logs, snow logs, earthquake logs, and other natural logs. Shear force and bending moment diagram. The shear force and bending moment diagrams of the beam are those in which the internal shear force B and the internal bending moment M can be determined in the different section of the beam. Then for this diagram, the section with the subject bending moments and the excessive shear force are determined. As we can see in the following example, we have the shear stress diagram. This depending on the log and stability will generate a force in each structure. That is the frame and the beam. Frame and beam. Likewise, is we generating a force diagram. How we can see which is well represented to the log and that part of the structure will receive and log. It will affect what the wall structure is in general, either by the weight is correct or by the magnitude of the force that is produced. To finish, we have the behind moments diagram, where we can see more time and see how they are represented in the beams, who we can see here in this part. This is because, as we can see in the modeling, they are only columns and beams. Who can see we that the columns serve as support for the beams. So we can only observe behind the moment in what the banks are. Wells have positive and negative charge. They are reflected in the diagram, here and here. Their charges vary according to the force that are expressed on the structure, as is the case with modeling, where it is only a structure of a building. As we can see, there are no external or internal loads that modify the behind moment in the ground. Thanks for watching. Finally, project.